In this lesson, we're going to take a look at single displacement reactions. So single displacement reaction is when one element takes the place of another element in a compound. So we start off with an element and a compound. So element on its own, compound at least two different types of elements. And then this element takes the place of this element. So that's now on its own, and this element is now in the compound with the other element or elements there. So just a visual to show you. So the red here gets kicked out by the yellow, which now pairs with the blue. So if we have a metal element, then that can replace another metal element. So metals in a compound are always written first. So if we have a metal, that's written first in the compound. This metal is more reactive, so it's going to kick B out, and now that is paired with in the compound. So because it's metal, comes first. So an example is lithium and silver chloride. So lithium is going to kick out silver, so that silver is now on its own as an element, and lithium oxide is the new compound that is made. If we have metal and acid or water, then the metal will replace the hydrogen from acid or water. So water we can see as a hydrogen and a hydroxide. So the metal would replace the hydrogen and pair with the OH, and we would make hydrogen gas. And with an acid, normally we have hydrogen paired with something else for our acid. So the metal will kick out the hydrogen and then be paired with the other portion of the acid there. So for example, this is the general form. So the metal is going to kick out the hydrogen that is either with OH, so that would make water, or something else that makes it an acid. So now water has split into H2 and then the OH, which would go with that metal, or hydrogen gas and whatever that acid was. So for example, sodium and water. So that's sodium and water. So remember, water we're going to see as H and an OH, and sodium's going to exchange with that hydrogen. So that is going to make NaOH and hydrogen gas. So hydrogen won't go off as one atom on its own, it's diatomic. So this isn't a balanced equation, but this is the skeleton equation. So if we were to write this as the word, so we have sodium hydroxide and hydrogen. Okay, so if we wanted to balance this, I can put a 2 in front of here. So this is also where it becomes helpful to see this as a hydrogen and a hydroxide. So I have 2 hydrogens which were kicked out by sodium. So if I had 2 of these, I would also need 2 of those OHs. And then that means that I would have needed 2 waters, so each one to give off the 1 hydrogen. And so that now gives me 4 hydrogen. 2 plus 2 is 4. I have 2 oxygen, and 2 sodium, and 2 sodium. And if we have a non-metal as our element, that is going to replace another non-metal. So non-metals are always written second in a compound if we have an ionic compound. So this non-metal, if it's more reactive than this non-metal, will kick that out and then is written second. So the metal comes first. So for example, fluorine and sodium chloride. So fluorine is going to kick out the chloride, so chlorine is now going to be on its own. So I'm going to have sodium fluoride and chlorine. So how do we predict whether the products can happen or not? Because if we look over here, fluorine kicked out chlorine, but if I started with sodium fluoride and chlorine, would chlorine kick out the fluoride? And that has to do with reactivity. So we have something called the activity series of metals, and that is in your data sheet here. So the activity series of metals right there. And this is just a mistake where there's an extra box in there. There's nothing missing from there. So the way that this works is whatever is higher up is the most reactive, and if something is more reactive, then it as an element would kick something else out and be in a compound. So a reaction would happen if the higher up in the reactants or out of the reactants is the element. Then it would react and kick that out, and that element would then be in the compound. If the element is lower than the metal or non-metal part of the compound, or sorry, the metal, because this is the reactivity series of metals. So if the metal that is the element is lower in this, then there would be no reaction because it's less reactive, and that won't happen. So the first one we had was with lithium and sodium. So lithium was on its own, sodium was in a compound. Lithium is higher, so it's more reactive, so it would kick sodium out. If I had it as sodium in the as the element and lithium in the compound, then we would look here and say sodium is not more reactive, so it won't kick lithium out, so that would be a no reaction. So the activity series of metals there on that data sheet can be used, and then for non-metals, the activity series of halogens, which is just based on reactivity, and because halogens have 7 valence electrons and they want to pull in one more, this is where the trends from unit 1, so the atomic radius here is what determines the reactivity. So fluorine has its valence shell very close to its nucleus, so we only have 2 shells of electrons. So that electron that's being pulled in is very close to the nucleus and the electrostatic charge that is exerted by the nucleus. So it is the best at pulling in an extra electron. As we move down, that valence electron is always 1 shell further away from the nucleus, which means that we have a lot more shielding happening of the electron shells in between the nucleus and the valence shell. So the more shielding levels there are, the less pull there's going to be. So as we move up the halogens, we have an increase in reactivity. Okay, so this just goes over what I said. So whatever element is higher up is more reactive, and then that will displace the lower element. So if the element is below, whether we're talking about the halogens for nonmetals or in the activity series of metals, if it's below, then there's no reaction, and we just say NR after the arrow to say no reaction would happen, so there are no products there. So for example, I have nickel and lead to nitrate. So I'm going to take a look to see where nickel and lead fall. And so nickel is the element on its own. So nickel is over here, lead is below. Nickel is more reactive, it's higher up. So that means that nickel will kick lead out, which means I'm now going to have nickel nitrate. And then lead is going to be the element on its own. Fluorine and potassium bromide. So this time we're looking at the halogens. So the higher up, the more reactive. So I have fluorine and bromine. Fluorine is more reactive, so fluorine will kick out the bromide. So I'm going to have potassium fluoride, and bromine will now be on its own. And last one, silver and sulfuric acid. So here, we haven't talked about this part of the activity series yet. So hydrogen, whether hydrogen gets displaced or not, there's a separate column here. So for acids, anything that is above here, so anywhere from lithium to tin, will displace hydrogen from an acid, and anything that is sodium or higher would displace hydrogen from cold water. So we were looking at silver. Silver is lower than that, so it is not going to displace hydrogen from the acid, which means that this is going to be a no reaction, because hydrogen is more reactive than silver, so it's going to stay with the acid there.